to dive into some vintage Java. We're cracking open Teach Yourself Java in 21 Days, first edition from 1996. Imagine, no smartphones, the internet's just finding its feet, and this book. Well, it's a time capsule, a snapshot of Java in its infancy.
It's amazing how it captures that early excitement, you know. Right from the start, Java was all about write once, run anywhere. WARA. Even the acronym sounds like something out of a sci-fi novel.
Wow, catchy, but why was that such a big deal back then?
Think about it, in 96, different operating systems were like separate countries speaking different languages. Java's promise. Write your code once, run it anywhere on any of those systems. It was huge for developers tired of rewriting the same code over and over again.
So more than just a cool slogan, it solved a real problem. And isn't that what we still want today? I mean, look at how we use apps seamlessly across phones, laptops, everything.
Exactly. That write once, run anywhere philosophy. It's still a cornerstone of Java's success today. From those early days to now, it's been about unifying the way we build software.
It's wild to think this language born in the dial-up era is now powering so much of our digital world. Speaking of which, the book mentions Netscape Navigator. Remember that browser?
Ah, Netscape, the king of the internet. Well, at least back then. The book talks about it as the main platform for Java applets, those little interactive programs that lived inside web pages.
Applets, right. Those bring back memories, like those little animations or basic games you'd find on websites, right?
Exactly. Think of applets as the early ancestors of all the dynamic stuff we see on the web today. They were a glimpse into what the web could be, but not without a few bumps in the road, like security headaches.
Yeah, the book even talks about concerns about applets being risky. Were they really that dangerous?
Well, any new technology comes with risks, right? Java tried to limit what applets could do, like they couldn't access your entire computer's file system, a way to prevent malicious code from wreaking havoc.
So it's like they were trying to walk a tightrope, enable this cool new web interactivity, but also make sure it didn't turn your computer into a hacker's playground? Sounds familiar, right? It's a challenge we still grapple with today.
Absolutely. It's fascinating how those early security concerns in Java foreshadowed the broader internet security landscape we have now.
So we've got this write once, run anywhere promise, early attempts at making the web more dynamic with applets. But what was the real magic happening behind the scenes in Java?
At its heart, Java was built on something called object-oriented programming, or OOP for short.
OOP. See, now those three letters always sounded kind of mysterious to me, like some secret code only programmers knew.
Well, it's actually more straightforward than it sounds. Think about a cookie cutter. That's like a class in OOP. It defines the shape, the properties of something. Now, every cookie you cut out, that's an object, an instance of that class.
Okay, so the cookie cutter is the blueprint, and each cookie is like a unique creation based on that blueprint. I'm starting to get it. So what happens next in this OOP world?
Well, that's where inheritance comes in. Another cool OOP trick. Let's stick with the vehicle analogy. You start with a general vehicle class, right?
Yeah.
Then you can make more specific classes, like car or motorcycle. Each inherits the core properties of a vehicle, but adds its own unique twists.
Ah, so you're not reinventing the wheel or the motorcycle for that matter every single time. You're reusing code, keeping things neat and organized, and ultimately making it easier to build bigger, more complex programs.
Exactly. And just like with real-life vehicles, in OOP, the possibilities are pretty much endless. You can build anything you can imagine.
You're making me want to build a whole fleet of Java-powered vehicles. In code, of course. Okay, so we're back in 1996 with our Java time capsule. And this next part caught my eye. It's called garbage collection. Sounds kind of mysterious. Does Java just clean up after me?
In a way, it does. It's like Java's built-in housekeeper automatically reclaiming memory that's no longer needed. No more memory leaks, no more crashes. Java takes care of it all.
That's pretty amazing. So other languages back then, they didn't do that?
Many didn't. Programmers had to manage memory manually, which was a recipe for disaster. One tiny error, and boom, the whole program could crash. Java's garbage collection freed them from that burden.
I can see why that was a game changer. This seemingly small thing actually made a huge difference. It's all about making life easier for the programmer. And speaking of easier, this book then goes deeper into OOP, even using a motorcycle as an example. Were motorcycles like the big thing in programming back then?
Well, remember, this book wasn't just for hardcore techies. They wanted anyone to be able to pick it up and learn Java. So using familiar examples, like motorcycles, helped make these abstract ideas click.
Makes sense. It's about bridging that gap between complex code and everyday experiences. Okay, so we've covered classes, objects, inheritance. there's this other thing that threw me for a loop. Native methods. Why would Java, which is supposed to be platform independent, need to call on its older brother C?
Ah, good question. It's all about balancing portability with performance. Java's designed to run on anything, right? But sometimes you need to tap into specific hardware features or squeeze out every last bit of speed. That's where native methods come in, often written C.
So like a backdoor in Java, a way to unleash the raw power of the system when you absolutely need it.
Exactly. Imagine you're building a game, something really graphics intensive. You might use a native method to directly talk to the graphics card for a performance boost Java alone couldn't give you.
It's like bending the rules for those extreme cases. And it shows how practical Java's design is. Sure, it's about write once, run anywhere, but it also knows when to adapt. You know what else surprised me? For a language obsessed with running everywhere, this book spends a lot of time on performance optimization, like a whole chapter. Were computers really that much slower back in '96?
Oh, absolutely. We're talking a fraction of the power and memory we have today. That's why that optimization chapter is so fascinating. It shows the lengths programmers went to make Java run smoothly on those limited machines.
It's a testament to their creativity, squeezing every ounce of performance out of what they had. But it wasn't all about hardware limitations, was it? Toward the end, the book hints at a much bigger vision for Java. Something beyond just making code run faster.
Oh, yeah. They start talking about a future where software is built from smaller parts that seamlessly communicate over a network. It's almost eerie how accurate they were.
It's like they could see the future back then. Wild, right?
Totally. They talk about software components swimming in a sea of network facilities. Such a vivid image for 1996. But fast forward to today. Cloud computing, APIs, everything connected. They practically nailed it.
Mind-blowing. It makes you realize all this stuff we take for granted, it all had to start somewhere. And with Java, it started with a vision.
And more importantly, with the right principles to make that vision a reality. Write once, run anywhere. Object-oriented design that focus on security and making the developer's life easier. These weren't just technical choices. They were building blocks for the future.
It's the foundation that's allowed Java to evolve, to adapt from those clunky desktops with Netscape Navigator to today's world of billions of devices.
Right. From those basic applets to these massively complex systems, the scale is mind-boggling. But you look closely, and those core principles, they're still there, underpinning everything.
That's what makes looking back at tech history so cool, isn't it? You see these patterns, these fundamental ideas that endure even as everything around them changes.
Totally. It's about understanding those timeless principles because they're the key to building technology that lasts.
So as we close the book on early Java, literally it makes you wonder, knowing what we know now, what's next? What does the future hold for this language?
$1 million question. But if I had to guess, I'd say Java's not going anywhere anytime soon. It's got the adaptability, the solid foundation to keep evolving alongside whatever comes next. Who knows? Maybe even shape it.
Maybe someday someone will be digging through old code from our time, wondering how we ever got anything done. But one thing's for sure. It'll be an exciting journey to watch and to be a part of. Thanks for joining us for this deep dive into the world of early Java. Until next time, happy coding.